So I want to talk a little bit about simplifying data science workflows on Ubuntu. Now, anybody who knows me would wonder, why the heck is Ken here talking about data science? I am not a data scientist. I will tell you that up front. I am not. Everybody would look at me and say, you're the desktop guy. What do we care about this on desktop? Well, a couple reasons. One, the primary use case here that we're looking for is simplifying it on your workstations. We have other solutions as well, but we're thinking about how do you do data science on your workstation. So that is definitely a desktop thing. But really, the problem we're solving is deployment. How do you install and get your data science environment set up on your system? And my expertise is actually building and deploying custom systems for over 30 years now. I've been doing software distribution for Linux for over 30 years now. So this is very much in my wheelhouse. When I do, you have a fancy NVIDIA GPU on your system. You want to make sure you can run those things that need CUDA, things like that. Having the right versions of the drivers installed, and you install these packages, repositories, or you find some online guide that has you run a shell script that you've used curl to fetch and pipe it through sudo, whatever, run the shell script that installs a bunch of junk on your machine. For one, you don't really know what that's doing, right? You don't know if you're going to get a working environment at the end of that process, and it's not reproducible, right? Like you can't set up your machine and then 6 months later say, I want to send the stuff I've been working on to my colleagues sitting next to me and get their environment set up so it works correctly. You don't really know what you have. So what we've been doing is we've been working on solving these sorts of problems, simplifying that process of getting your system in a workable state in a reproducible fashion. So who cares about this? It's really anybody who wants to get started in AI. Like if you want to do some data science, machine learning kind of workflows on your machine and you don't really know where to get started, this is a great place to start. Or if you've already been doing it, but you're frustrated because things are fragile, this could also be a great solution. Our PC OEM partners care a lot. You know, they sell these very high-end, expensive workstations with big, beefy GPUs for this kind of use case. But they want a way for data scientists to get off the ground running when they buy these, expensive workstations. And enterprises with large numbers of workstations trying to do AI stuff, right? Because you want reproducible environments. You want to be able to build reproducible environments that can be used across your enterprise. There's a few parts to this I'll get into a little bit more later. But we have this concept, canonical MLOps. I'll talk more about that a little bit later. But part of what you get out of the data science, our data science stack, is MLflow, which is a tool for kind of managing your experiments, your models. You can version your models. So as you're tuning things, you can have new versions of it. And then you can go back to old versions. You can compare results between them. You can manage your experiments that you're doing through MLflow. And it also comes with Jupyter Labs built in. So whenever you set up any of these containers, you get a Jupyter notebook essentially as your vehicle into it. A little bit about the architecture here. So we have Ubuntu here, right? We're using microK8s as our Kubernetes distribution, but really our data science stack works with, theoretically should work with any Kubernetes distribution you want to use. But in our example here, we'll use deploy K8s on your workstation, particularly targeting, the work you do on your desktop. Then we have Jupyter Lab notebooks. You can bundle CUDA and the containers, piping up a new notebook to do work in a new project that you're working on. You create a new container, and you're off to the races. So it's really simple to install. It's kind of the point. That's what I was talking about, trying to make it easy to get up and running quickly in a reproducible kind of fashion. It's distributed as a snap. So I can definitely talk a lot more about that. But I'm in the community, but people are coming around. It's great because it's portable, right? It includes everything needed in runtime. Something could be tested on Ubuntu 24.04, but hey, you're still running 18.04. It's going to work. It's going to work exactly the same way it worked on 2404 on 1804. If you're It should work on OpenSUSE too. I know all of the snaps I maintain, I test on Fedora, Debian, Arch. I do not test it on OpenSUSE. I maintain or work on all those distributions. I will say I've never tested this or Data Science Stack on other distributions besides Ubuntu, but it really should work because, like I said, it gives that entire portable runtime there. Along with it. And there's some built-in confinement stuff, sandboxing, which is really nice, so applications can't access things it shouldn't access, things like that. But also, when you're done, if you don't need to do this anymore, do you really need to keep all these things laying around on your machine, maybe containers running, etc.? You can actually just snap remove Data Science Stack, and it will remove every trace that it was ever on your system, which is pretty nice since it's all very isolated in its own environment. Demo time, this will be fun. Since I actually can't see my screen here. Give me a second. All right. I'm going to start off by showing you the documentation here, because I'm actually not going to install this live on stage with flaky Wi-Fi. Okay? So I do have it all set up on my machine already, but as you can see here, oh wait, this is the wrong. All right. So there's just a few steps. It requires installing microcates. Like I said, this is our Cates distribution that's designed for your workstation, desktop, laptop, etc. It's designed to run just on a single machine, which is perfect for this kind of use case. You have to enable a couple of plugins in microcates. So there's a few commands to run there. Then a simple snap install of the Data Science Stack snap, which is just one command, which is great. And then we have to initialize the Data Science Stack. So you've installed 2 snaps, enabled a couple plugins in microcates, all very quick. Then we need to initialize the Data Science Stack. And the reason why we have to do this is I mentioned the Data Science Stack will work really with any Kubernetes distribution you have. So we need to run the DSS initialize command and pass it our kube config. So that's our configuration so it knows how to talk to your Cates cluster. So in our case here, we'll run a microcates command to output the config for it. So then our Data Science Stack will be configured to use your Cates, the Cates that is installed on your machine. All right, and then we're ready to create a notebook. Let me bring a terminal over. Hopefully that's not too big. All right, so there's a number of DSS commands. I think this will tell us all the commands possible. So you can create a new notebook. Initializes the command we already talked about. It initializes the Data Science Stack. List will list any existing notebooks that you've and not using one of these containers to have this thing running and using your GPU and things like that, right? So you can stop them when you're not using them and start them when you do need them. I'll show you what status looks like. So DSS status here will tell you the status of your instance, and it'll give you a URL, it's a private IP address to access MLflow. You'll notice here it says NVIDIA GPU is disabled, and so is the Intel GPU is disabled because I don't actually have an NPU or GPU that's compatible for Intel, and I do not have an NVIDIA in my machine. If you did have an NVIDIA GPU, or a discrete Intel GPU that you want to use, there's another command in microcates to enable the GPU operator, which is also documented on the documentation website. So it's a single command, enables the GPU operator for NVIDIA, for example, and then this line here will show the GPUs available, and then you can use CUDA stuff and things like that inside of your container. If the GPU is passed through, that should work, yes. Yep. So really what we want to do to get started here is if you do create -- help, this will give you some guidance on where to get started. There is, you can specify any image you want with the container registry reference, so you can fetch any image that's in a container registry that you would like, but we have some predefined ones. So if you just want a PyTorch one, you can create a notebook, name it whatever you want, -- image equals PyTorch. Or if you want a PyTorch with CUDA included, you can do PyTorch - CUDA. And again, these things get set up with all those tools installed inside of the container, so they're not kind of tainting your system, right? You're not installing arbitrary things from other repositories on your desktop system. You want your system to be reliable. You want to know what's running on your machine. You can just deploy these things inside of these containers. So I have, as I said, I preset up, because it's not my first demo. I've got a couple notebooks here. I've got a PyTorch one and a TensorFlow one set up. Actually, the demo I'm going to do doesn't require PyTorch or TensorFlow, but I'm going to use the PyTorch one that I have. And you see there's a URL there that I can click on to go to it as well. I'm actually going to move this whole screen over here. All right, so this is, let me go to this other one actually first. So this is the TensorFlow notebook that I have. If you're not familiar, Jupyter Labs, this is a very, very common tool for data scientists to use. You essentially you can get like a Python shell in here where you can write some Python code and execute it. You can get a terminal inside the container where you can install packages, whatever you need to do, all through this kind of single interface. So this is inside of that TensorFlow container. And write a little bit of Python and hit run, and you see you can run that little line of Python, right? So this is a notebook. Another interesting feature here is you can actually drag this notebook into the shared folder there, and then go to another container that you have, and go to shared, and you can see the one that I shared from the other machine. So they're all automatically connected, and anything you drop in that shared, you can say, I've been running this other one, this other instance, I want to move it to this one. You can just drop it in the shared directory there, and it'll work. So the demo I have set up for today is a simple, it's a public model for comparing wine quality. Okay, it doesn't require a GPU. It's very quick. My little, 6-year-old Intel laptop will not barf here when I try to run this. So essentially, I've got this notebook that I've prepared that has some markdown that explains what's happening, some Python code that will run, and you can just step through this in the Jupyter Notebook, and it will run each step. So you can see it just ran the 2 markdown ones, which do nothing, and this one here is, oh, well, I hope this doesn't blow up. That wasn't supposed to happen. It should be installing a bunch of Python. Oh, what happened? I do, but I have. Oh, I was connected on my hotspot, which seemed to be working before. Is there Ethernet here? I got one right here. I think I actually have a regular port here. Yeah, that's even better. Okay, thanks. That was great. I should have used that from the beginning here. All right, so let me make sure that I'm not. All right. Turn off Wi-Fi. All right, now let's. But this is actually running on my local machine. It should be fine. The demo, the live demo, always. Let me, I don't seem to actually have network. Yeah, I do actually. Okay. Maybe it will work now. I broke it. Yep, absolutely. All right, so let me, is that the upload icon? I can't see. Okay. Oops. All right, reopen this thing. All right. I can get back to where we were. Why isn't that actually outputting anything? Yeah, but I still think it would have spewed some output there. Well, let's see if this next one fails when I run it. Yeah, I think I need to restart the kernel thing here. Let's try that. Yeah, but I would think this would give me an error that it couldn't connect. It's like not even trying to run that. Oh, that's why. The status got changed to code, to raw, not code. That's running. There we go. Yes. Oh, sorry. So that first line of code in there was a pip install. Any line that starts with an exclamation point is like basically running a command. The other lines in here are mostly Python code, but this is installing all the Python packages necessary for this particular notebook. All right, so it's not quite done yet. But the way, if you're not familiar with Jupyter Notebooks, each of these little blocks here are separate steps, and you can run them all, or you can run them one at a time if you want, or you can rerun them. It's basically just executing whatever code's inside. The container's already been created. When I did the DSS create command, which I did not do on stage, it fetches the container and provisions it, sets it all up. And it sets up like that shared directory and things that I talked about. It sets up a connection to MLflow, which I'll show you in a minute, because when I run these experiments, it'll actually register something in MLflow, so you can see the results and compare and things like that for your tuning. Like you're talking about CUDA versions? Yeah, like CUDA versions. So the CUDA versions are usually reliably backwards compatible. I've definitely run into situations where we had to go back to it. So my question is there pinning built into, like, is that sort of pairing logic? Well, the NVIDIA drivers for your GPU is on your host system, so whatever version you have installed in your host system, and CUDA would be inside of the container. And whoever maintains that container controls what version of CUDA is in it. Yeah. Yeah, and you can create your own containers. You can point it to your own container registry, so like you could maintain the content yourself of what will be in these containers. So if you want to, kind of create one that you can use throughout your enterprise and have your own container registry, it's pretty trivial to do that.
Actually, I've got a good example. I ran a container that was designed specifically for Kepler video graphics, accelerators. So it used Kepler's antiquated CUDA. And the current, I think 12.8 CUDA doesn't necessarily always play nice with that code. Right. So yeah, I exactly. I've run into exactly. Right. But there, I mean, you can go up to near bleeding edge on the time, but if you step over incompatibility,
Okay.
I'm just wondering if there's that logic that you're saying it's outside.
Yes, but if you craft your own containers, you can control what version's in that container. All right, so now we'll go to the next step. That one's done. So all the Python modules are installed, and this one really just is a few imports to get the environment set up. That should have just run. I don't think it outputs anything. What's going on here? All right, this next step here, we'll download a CSV file of our data that we're going to use for our experiment. And I'm not getting any output here. That should have given me some output too. What is going on? I think one of these didn't work. Let's try running that again. That one might not output anything. This one definitely should do something. Oh, the joys of demoing with conference Wi-Fi. But it's definitely better. Okay, that worked. Okay, good. It worked this time. It did have a network failure the first time. So in this step here, it downloaded the CSV file and read that in, and did what it needed to do to get our data. And then here, this will set up our MLflow experiment, which I'll show you in a minute, which you can, well, actually, let me go to MLflow first and show you there's nothing there. All right, so this is MLflow. We have currently no experiments, and we should have no models. Okay, so it's empty. And we can go back to here and run this step, which will register it. All right, and we can keep going, do another. Here we'll run multiple training sessions. So this will output more stuff. There we go. All right, so this is where it's doing the training on our model. This one is, yes. It can. Yeah. So the containers that I'm using are containers that are built by the Kubeflow project. But again, you can point to any container registry you want, pull anybody's containers. You can share containers. Well, so MLflow is a tool for kind of going back and viewing the data, the results. So you can look at your models, you can look at the experiments output, you can do multiple runs and compare the results. I am not an expert in that area. I do not honestly really know what I'm talking about there, but that's what MLflow is about. You can see the different runs you do, like we could run this a bunch of times, and it'll register each one of those in MLflow, and then you can go select 2 of them and compare the data results. So it's just kind of a way to manage your experiments and manage your models. Yeah, so, and Jupyter Notebooks doesn't directly integrate with it, but in here, the Python code we're running to do this work has some MLflow Python API calls that says go register with my MLflow. Register this experiment, here's my model, register this model with MLflow, version it. I want to version, this is version 1 of my model, this is version 2 of my model, and then you can go back into MLflow and look at all that data anytime. And you can, 6 months later, go back to an old experiment you did and look at that result. All right, I think that is done. Yes, created version 1 of the model. I think it says version 1, all right. Now we can register that with MLflow. All right, that's done. This is actually uploads the model to MLflow. And then let's generate an extra artifact. So we'll use a matplot to generate a nice little graph of our results. And there's a little chart that was created, scatter plot. Now we can go to MLflow and let's refresh this. And now in MLflow we have the model that we produced there and our experiments and the different runs. So that one run created all of these, and I can go drill down in here and look at various aspects of it, but I can't see the screen well enough to really do that. But you could select 2 different ones and do a comparison. Let's see what that looks like here. I'm not actually, there we go. And there is that the compare? I think it is. So there's not a lot of data there to compare, but you see you get a UI to look through your experiments and compare those results. Okay. All right. And where is my other window here? All right, so some of the benefits, I already mentioned some of this, is, it's really built with the developer in mind. It's 100% open source. It's native to Ubuntu, but it doesn't have to only work on Ubuntu. You could use it elsewhere. Run anywhere, desktop, cloud, the edge. Actually, a lot of these same tools. We have a charmed kubeflow, which gives you some of the same MLOps capabilities, but if you want to run it in the cloud, for example, as opposed to on your local workstation, the flow is very similar. One vendor for the whole ML lifecycle, so basically you don't have to go and download this from so-and-so and this from somebody else and try to make it all work together. We've done that integration for you. Getting started is easy. The data science stack is really kind of the first step to do your local development on your local workstation. And once you kind of prove things out or you get to the point where you want to collaborate with some other folks, you could actually scale that up and do, I guess we'll talk more about charms later with the Juju talk, but you could actually have something that runs on the cloud somewhere. Then you could share your models and have that same MLflow kind of experience, but not just on your desktop. And then ultimately deploy to the edge. Like maybe you're training your model because you want this thing to do some inference on an edge device somewhere, and you can ultimately deploy that to the edge. But that's done outside of data science stack. So as you can see here, the data science stack is really built for that first two steps, the build and optimize. You could use Charm kubeflow to do the entire thing. You can do everything, even the deployment, which you can't do with the data science stack, for deploying stuff to run like in production. But it's a great developer environment. So some of the value adds here for our ML ops, like I said probably 15 times already, reproducible and predictable. Like you want to be able to set up your environment and set up another workstation exactly the same way. This is really your best bet. This is the best way to do that. And again, the same technologies can be used in the cloud, so you can roll out this sort of thing once you're comfortable using this and just deploy it somewhere else and then do that shared sort of development kind of model. And these are some of the enterprise kind of use cases here. Obviously workstations, we have smack dab in the middle there. Imagine you go buy your Dell workstation with 4 GPUs in it, and you really want to be able to do some great development. These partners want you to be able to get up and running and utilize that hardware and get the most value out of that hardware. So they really care about this. This also works in WSL. So if you're on a Windows system and you want to deploy the same sort of stack, the process to getting it up and running is exactly the same in WSL. So you could be on a Windows machine and still use the data science stack in WSL. Please install and provide feedback. So it's, like I said, it's available in the Snap Store. I will provide links to the demo that I use. So if you want to play around with it yourself, the notebook, I will provide links to that. I will provide links to our Matrix channel where you can talk to the data science stack and kubeflow developers that work on these things. And I will, and I'll share a link to the documentation as well. I'll share all that on Mastodon and I'll tag UbuCon later. So take a look there if you're looking for it, and feel free to hit me up afterwards if you guys have questions. We have some time for questions now, and I think I have Stefano on a Google Meet here. Is he here? Oh, I think I lost him when I disconnected the network. It hung up on him. Okay, great. Well, while this thing thinks about joining, so Stefano is our product manager for the data science stack. He couldn't be here today, but he is supposed to be available for questions if I can get Google Meet to connect. Do we have any questions? Why don't you get started asking?
Yeah, I'll run the mic to you. I'll run the. I got. Okay.
Okay.
All right. There we go. Sorry. Hardware is hard. I'm a software guy, but yeah. So I'll run the mic to anyone if you have a question. That way, people on the live stream and also the recording can also hear your question as well. So that way, everyone can participate.
I'm just curious. I never tried, but I saw you using the TensorFlow and PyTorch in the container registries. I was just curious, like, can we also use LLM models, which are going on right now a lot, to be deployed on these container registries, and maybe it can run on this entire notebook itself?
If I understand your question correctly, that's probably a better question for Stefano, our data science guy. But I think the answer is probably yes. I mean, you should, anything that you can get into the container, you can use. Like you can fetch a model that's already been pre-trained and then do additional work on that. You should even be able to upload that model into MLflow and then access that from inside the notebook. Does that answer your question? Yeah, okay.
Any more questions? Hey, here you go.
Hi. So it seems to me that, and I'm not familiar with Jupyter Notebooks, I guess, but it seems to me that running pip install, especially if you're sharing work with other people, gives you a chance to, I don't know, lose access to a version of a package and blah, blah, blah. Are there any ways or functions you can talk about of building and sharing containers as it's related to this, or that's something that's sort of outside the scope of your project?
I would say it's related. So yes, I used pip to install some Python modules from the Jupyter Notebook, but also inside that Jupyter Notebook, you can get a terminal, and in that you can use like apt to install packages, for example, things like that inside of that container. But also, as I was talking, you could create your own containers that can then be shared, so your colleagues can use the same container. So maybe that container has all the Python modules versioned the way you expect, so you don't have to use pip. So it's reproducible. Back there?
All right, I got the.
Yeah, you could specify versions in that too. But I get the point though, as far as reproducibility, right? Like what happens if that version is no longer available a year later and somebody tries to run this thing? I mean, I have seen it happen. But again, you can craft your own, and I would definitely encourage like enterprises that want to have reproducibility to craft their own containers and use their own container registry. So then you can point to this container and then you're grabbing the same container that your colleague used for the same experiment.
Marshall, wait. Talking to the mic so everyone can hear you.
Sorry. I'll also let you know that it is also possible to create a virtual environment inside the Jupyter Notebook, so you can technically build data outside of the container, right? As long as you have a mount, you can basically store every package that you would need, and you can share that with other users as well. If you're curious, I maintain one of those machine learning containers myself. It's called CTPO, CUDA, TensorFlow, PyTorch, OpenCV. And I actually have a description in the GitHub on the entire process for exactly that. I like to run those things within Podman, so I can basically drop down to being myself, right? Not root within the container. Happy to talk more about that later if you're comfortable.
Any more questions? All right. Well, thank you, everybody. I appreciate it. If you have other questions later on, I'll be here all day. Feel free to hit me up. If you want to talk about other things Ubuntu or snaps or whatever, also hit me up. I'm always happy to talk about those topics. So thank you, everybody.